Hello everybody, my name is Jeffrey, and the last tutorial we created this cube rotated around the X, Y and Z axis by 45 degrees. However, well, it's not proportionized properly because we are currently using a the OpenGL coordinate system from -1 to +1 on X, Y and Z axis. In order to make this a bit better, we're going to apply a perspective projection matrix, and this will, well, it'll look more realistic because currently we are looking inside the 2 by 2 by 1 box that OpenGL creates for us, and we're going to, well, sort of scale that box so that it matches our preferences. So close this off and let's get started. We're going to go over to our transform class, and we're going to create a new method. So public static matrix 4f get perspective projection, and we're going to take in a few variables, for example the int width, int height, float z near and float z far, and we'll also want to take in a float value for the field of view. Someone is messaging me a lot, but he'll have to wait until I'm done with this tutorial. So matrix 4f dot we'll just return it. Return new matrix 4f dot init perspective. This one takes in the field of view first, so we'll do that later on as well. So we'll copy this set of data. So float field of view, int width, int height, float z near and float z far. Okay. These variables basically mean, what these mean are field of view. So how much can you see? Well, if you look right in front of you, there's a most left and a most right thing that you can see, and the angle between those two is your field of view. In video games it's default to use a field of view of 70, but people with large screens most of the times will prefer 90 or sometimes even higher. So, but we'll just stick to 70. So let's create a method which will update the projection matrix in all of our shaders, because, well, it is something that has to be equal across all shaders. So private void update projection, and we're going to take in a float value for the field of view, a int width and int height, a float value z near and float z far. I wasn't quite done explaining what these variables were. What was I? No. Okay, the width of your window, the height of your window, how close something must be to you in order for it to be rendered, and how far may something be. So this is basically your render distance, and this is where you want to start rendering. This will be 0.1 for in most of the cases. So what we're going to do is we're going to create a new matrix 4f projection matrix. We'll store that in this class, equals new matrix 4f dot transform dot get perspective projection. Just copy all of that. We'll create our matrix for f variable over here, so private matrix for f projection matrix, I believe. Copy this. Yes, okay. Next thing. Basic shader dot bind and basic shader dot update projection matrix. We haven't made this method yet, but we'll do soon. And after this, shader dot unbind. We'll have to call this method actually. So go over here. Init per. Well, no. Well, I forgot what to call this method. Update projection, yes. Update projection. Field of view of 70. I'm just going to hard code these variables for now. 1280, 720. Z near will be 0.1 f, 0.1 f, and 1000. Those look like good variables. Okay, now go over to your basic shader class and create a new uniform for the projection matrix. So I'm going to add it in front of the world matrix because that way it's alphabetical, well, sorted alphabetically. Well, that's probably good English. Add uniform projection matrix, and we'll create a method for that. So public void update projection matrix for f and I'm going to take that in. I'm going to add matrix after this. So set uniform projection matrix, and we're going to set it equal to projection matrix. Easy. Now we'll have to change our shader code, so we'll take in another uniform over here and a projection matrix. And be sure to apply your projection matrix before your world matrix. So Java, go over back to Eclipse, run. We'll have to change the camera position a bit. So up, master renderer. I'm going to move this over here so that you can see better, and we'll move it a bit on the z-axis. And there it is. It's our, well, not perfectly. It doesn't have a perfect well, aspect ratio. I don't know which word I'm looking for exactly, but as you can see, it does already look more like a cube which has been rotated 45 degrees on all axes. So yeah, that was it for this tutorial. So I hope I see you in the next one. Bye.